Good morning. With us being out today, here is your mini lesson to review solving systems of equations by substitution. Let's take a look at some examples together following the guided steps. Step 1. Isolate the variable in one of the equations. So as we look at these two, the first equation is the easiest because y has no coefficient. However, you can isolate either variable. Using our inverse operations, subtracting 2x from both sides, leaving us with the equation y equals 5 minus 2x. We have now isolated for one of the variables, completing step 1. Step 2. We now want to substitute the isolated variable that we just got into the other equation. So we have the equation 4x minus 2y equals 6. And we're going to substitute our equation that we just got for y and replace it with the y. So that would give us 4x minus 2 times the quantity 5 minus 2x equals 6. That now results in an equation that has just one variable, so now we can solve that equation. Applying our distributive property, that gives us 4x minus 10 plus 4x equals 6. Combine our like terms, so we get 8x minus 10 equals 6. Using our inverse operations to isolate, adding 10 to both sides of the equation, results in 8x equals 16. Divide by 8 to undo multiplication, resulting in x equals 2. That takes care of both steps 2 and 3 as we substituted the isolated variable in and then solved the equation. Step 4. We're now going to take the variable that we just solved for and substitute that solution into the other equation to solve for the second variable. And we can pick any equation we want for this one. Since y has no coefficient, I'm going to go back to that first equation of 2x plus y equals 5. We just found out that x equals 2. So I will then substitute that in for the variable x, leaving us once again with a one variable equation. So now we solve for y. Using our inverse operations to undo that addition, subtracting 4 from both sides, resulting in y equals 1. Last but not least, we recommend that you double check your solutions to ensure that they do work. Remember that an equation solution is an ordered pair that will make the equation true. So if we take the equation 4x minus 2y equals 6, and we plug in our x equals 2 and our y equals 1, we should get a solution of 6. 4 times 2 is 8, minus 2 times 1 is 2, and 6 equals 6. Therefore, our solution is the ordered pair 2, 1. All right, let's take a look at our example. Let's start with step 1, which is isolating the variable in one of the equations. Remember that you can isolate the variable in either equation. However, look to see which one will give you the easiest and shortest amount of steps. So in this case, the first equation has no coefficient on x. I would recommend starting with that one. Go ahead and pause the film and go ahead and isolate for the variable x in the first equation. Once you've done that, go ahead and replay so you can continue on to the next step. Okay, now that you're back and isolating that variable, let's just double check our steps. So x minus 2y equals negative 3. To get x by itself, we're going to add 2y to both sides, resulting in x equals negative 3 plus 2y. Step 2. Now let's take that x equals negative 3 plus 2y and let's substitute that into our other equation for the variable of x. Go ahead and pause the film and try that substitution on your own. Okay, let's see how we did. 7x minus 2y equals 15. And we are going to substitute the negative 3 plus 2y right in for the variable x. So that gives us 7 times the quantity, negative 3 plus 2y, minus negative 2 equals 15, leaving us with an equation all in one variable. So step 3 is we're going to go ahead and solve this using our distributive property. Gives us negative 21 plus 14y minus 2y equals 15. Combining some like terms, negative 21 plus 12y equals 15. Inverse operations, adding 21 to both sides of the equation using that additive property of equality. 12y equals 36. Then our division property of equality, dividing both sides by 12, results in y equals 3. All right, folks, you guys head on to step 4. Take our variable that we just solved for and plug it back into the other equation to find the other variable. You're on. Okay, let's see how we did. So now we're going to plug it back into our other equation. So we could go x minus 2y equals negative 3. So x minus 2 times 3 equals negative 3. Negative 6 equals negative 3. Inverse operations, adding 6 to both sides, resulting in that x equals 3. All right, last but not least, let's make sure we got it right. Pause the film one more time and go ahead and give it a check to see if x equals 3 and y equals 3 does in fact make the equations true. All right, let's give it a quick check together. So 7x minus 2y should equal 15. So 7 times 3 minus 2 times 3 equals 15. So 21 minus 6 equals 15. And 21 minus 6 does equal 15. So therefore our solution, which we write as an ordered pair, is 3, 3. Hopefully you followed along step by step and were able to get those right. Now let's try a couple on your own all the way through, then come back in to check them. One at a time, go ahead and try this one up first. Pause the film and come back to it once you have it fully solved. All right, let's see how you did on the next question. If you followed your steps, where you began first isolating for that variable, followed by, in step 2, Then taking a look at plugging it in, so we had all down to one variable, solving for x. Once we get that, we're going to substitute it back into the other equation. Now keep in mind, as you are substituting the variable that you solved for, you can plug it back into either equation to solve for y. Both will result in a correct answer. Once we plugged it back in and we solved for our second variable, remember that our last step is recommended that we check our solution by plugging in our x, y values and making sure that we in fact have a true statement in terms of our equation. So we should have gotten 2, 1, x equals 2 and y equals 1. Go ahead and try the fourth question on your own, then come back to check it. Alright, let's see how we did on that last question. Alright, in this one, the first equation is definitely our easiest to isolate for the variable. So we're going to solve and isolate for x, which resulted in the negative 2 minus 5y. Substituted in the other equation for x. Gives us everything in one variable. Now as we solve for y, using our inverse operations, we result in y equals negative 1. So we now take our negative 1, substitute it back into either equation to solve for x. Since this one did not have a coefficient, I felt it was the easiest to plug back into, just saving some steps. Solving with our inverse operation, we get x equals 3. Last but not least, I then used the other equation to go back and double check my work by plugging in x equals 3 and y equals negative 1, and we did get a true statement. Therefore, there's our solution. Now,